Welcome to another exciting video or lesson brought to you by Vision Concept Academy. Today we'll be looking at matrices, and at the end of this lesson we should be able to define matrix. We should be able to understand what is meant by equality of two matrices. Understand equality of two matrices. And 3, we should be able to add and subtract two matrices. Add and subtract two matrices. Number 4, we should be able to multiply a matrix by scalar and multiply two matrices together. Multiply a matrix by scalar and two matrices together. So don't worry, if you don't understand all these terms, just sit tight. Stay to the end of this video, you will understand these concepts we have on the board here. And if you have not subscribed, please subscribe to our channel to get more exciting educative mathematics video. Also, we offer physics and chemistry. So the first we have here is, what is a matrix? Actually, a matrix is defined as a set of real or complex number elements arranged in rows and columns to form a rectangular array. So, for instance, this is a rectangular array enclosed. So it is defined as a set of numbers. So I have numbers, let me just call random numbers, 5, 7, 2, I have 6, 3, and 8. So this is like an array that is formed here, and it's like a rectangular array. So the numbers are not connected by any way, but they are just enclosed in this array. Now, the matrix is, this one is a 2 by 3 matrix. How do I mean by that? Because I have this matrix having this side as the row and this side are the columns. This is how it's arranged. It's actually arranged in a definite pattern. Matrix arranged in a definite pattern so that you have a neat arrangement. So you have row. If you just see row like this, remember horizontal, RH, row horizontal. Column is CV, vertical. So the vertical counts like this are the columns, while the horizontal is the row. So this is how a matrix looks like. This particular one I'm giving you is a 2 by 3 matrix. It's a 2 by, they call it 2 by 3 matrix, this particular one. Why? Because I'm calling the number of rows before I call the number of columns. It is read like this, 2 by 3, but it's written like this, 2 by 3 times 3 matrix. So this is a 2 by 3 matrix. Why? Because it has 2 rows, 1, 2, and 3 columns, 1, 2, 3. So it's actually easier for us to understand. Okay, let me give us other examples of a matrix and define it by the rows and columns. If, for instance, I have another random matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's just random. It's not in definite order. So I have 3 rows, 1, 2, 3, and I have 4 columns, 1, 2, 3, 4. Just remember, row is horizontal count, and column is vertical, CV, vertical count. So this is a 3 by 4 matrix. 3 by 4 matrix. It's a 3 by 4 matrix. So that's how it is. Now, this matrix can be the numbers or elements. We call every number here element. The elements inside a matrix can actually be gotten by its position. So I can write the positional notation. There's a notation for it. Notation for it. If, for instance, I have a 4 by 4, let me do 4 by 4 so that it's complex enough. So the notation, the first one here, element is A11, okay? A11. So I have A12, A13, A14. You see, I'm calling the row before the column. So this is row 1, column 1, row 1, column 2, row 1, column 3, row 1, column 4. Here is A21, A22, A23, A24. Then here now is A31, A32, this is 32, A33, and A34. And here I have A41, A42, A43, and A44. So this is notation for the matrix by position. So you write it like this. There's the row before the column. So this is from looking at this row 2, this row 3, row 4. The first subscript number here is the row, while the second subscript number here is the column. So I have this is row 4. That means every first subscript here is 4. This row 3, every first subscript number here is 3. This row 2, every first subscript number here is 2. This row 1, every first subscript number here is 1. So this is the notation for 4 by 4 matrix. And if I have a mirror here, let me just put something here like this. 2, 4, 6, 8. Don't worry, let me just do like this. I'm just top of my head so that we can, let me do something different. 9 is 1, 2, 1, 3, 17, 20. Okay, now if I ask you now, this is already a 4 by 4 matrix. So if I ask you, what is A23? What will be the answer? A23. So this is 2. A23. A23 is a 7. So you should be able to pinpoint a particular element by its position. If I have A43, for instance, where is A43? This A43 here. A43 is a 17, and so on. Okay, let me put another one. A32. Type this one in the comment section. Let me see your answer. Type it in the comment section. A32. All right. So this is matrix, the notation for matrix. Now we are going to go to understanding the equality of two matrices. When would you say a matrix is equal or two matrices are equal? If the corresponding elements are the same. If the corresponding elements are the same. For instance, if I have this matrix, let me do a 3 by 2 matrix. A 3 by 2 matrix. 3, 2, 1, 5, 6, 7. This is a 2 by 3 matrix. It's a 3 by 2 matrix. Why? I have 3 rows and 2 columns. So a 3 by 2 matrix. If I have matrix like this, it will be equal to another matrix if every corresponding element of that matrix is the same. So this matrix is equal to this one. If this one is matrix A and this one is matrix B, they are equal because the corresponding elements are all equal. The corresponding elements are all equal. See? They are all equal. So A11 here is equal to A11 here. A12 here is equal to A13 and so on. If peradventure one of them changes like this, no longer equal. No longer equal. So that you have to inspect very well to see that every element is equal. That is for equality of matrix. So let's quickly move to the addition of matrix. Addition and subtraction of matrix. How do we add and how do we subtract? I'm trying to still leave the objectives on the board so that we can follow it one by one. how do we add and subtract two matrices? If, for instance, I have a matrix like this, a 2 by 3 matrix, that is 4, 5, 2, 7, then 3, 6. This is 6 here. Then they say we should add it to 1, 8, 9, 3, 5, 4. So you should add this matrix together. What you do is to add the corresponding elements to form a new matrix. Addition and subtraction of matrices is only possible if the matrix type is the same. So this is a 2 by 3 matrix adding to 2 by 3 matrix. It's only possible if they are of the same order. So this is a 2 by 3 matrix. Remember, 2 by 3 matrix. Why? Because it has 2 rows, row 1 and 2, horizontal, and 3 columns, C1, C2, and C3, like this. Like this. Remember, so 2 by 2 and 2 by 3. So addition and subtraction of matrix is only possible if the order is the same. Now, how do we add this matrix? We add the matrix by adding the corresponding element together to form a new matrix. So let's go. 4 plus 1. Make sure you map it. A11 and A11 here. 4 plus 1 is 5. So my new matrix A11 is 5. 2 plus 8 is what? 10. My new matrix is 10. My new element for A12 is 10. 3 plus 9 is 12. My new matrix. 5 plus 3 is 15. 7 plus 5 is 12. And 6 plus 4 is 10. So this is the addition of these two matrices. So ensure that each of the elements, they map each other in the addition. So when you carry out the operation, ensure that you map. The same thing applies for subtraction. If, for instance, you want to subtract two matrices, so the first thing, no matter how complex it is, they must have the same order. A 2 by 2 adding a 2 by 2, or a 3 by 3 adding a 3 by 3. The order must be the same. So if, for instance, we have this matrix 6, 9, we have 6, 9, 5, 4, we have 12, 8. 12, 8, okay, minus, we have 3, 2, we have 7, 10, and we have 1 minus 5. So we have to do subtraction of this matrix. So we are going to map it clearly, but first of all, inspect. You see that there are 2 by 3 matrices. The order is the same. So 6 minus 3 is 3. That's to form a new matrix. The first element there. 5 minus 7 is minus 2. 12 minus 1 is 11. 9 minus 2 is 7. 4 minus 10 is minus 6. 8 minus 5 is 3. So this is the new matrix form from that subtraction. Now, for multiplication of matrix, we are going to be looking at two kinds, by scalar and two matrices together. What do you mean by scalar? If we have a matrix like this, multiplication of matrix, right, in this objective now, multiplication of matrix, how to multiply matrix. The scalar is just a number. That is, in the world of matrices, a scalar is just a number. It is not a number inside another other set of number, because we said a matrix is defined as a collection or an array of numbers placed in a particular order to form a particular rectangular array. Understand? But a scalar number under matrix is just a number. So for instance, if I have 5 is a number, and they say we should multiply 5 by this matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a matrix. Why? Because it's a number that's arranged in a particular array to form a rectangular order. So this is a matrix, for instance, but this is a scalar. If they say multiply this by a scalar, this number is scalar, a non-matrix number, a non that is not inside the matrix, to multiply the matrix. Just take this scalar, this number, and multiply each of the elements to form a new matrix. So our new matrix is like this: 5 times 1, 5. 5 times 2, 10. 5 times 3, 15. This is the first column. Second column: 5 times 4, 20. 5 times 5, 25. 5 times 6, 30. Second column. Third column: 5 times 7, 35. 5 times 8, 40. 5 times 9, 45. Third column. So this is what will come out from multiplying a scalar, with a matrix. The same thing, you can factor out scalar from matrix. You can factor out scalar from matrix. Okay, let me get an example where we can factor out a scalar from a matrix. So if I have this matrix, I want to put a 2 by 3 matrix on the board. A 2 by 3, we call it 2 by 3 because 2 there represents columns, rows, 2 rows, and 3 there represents 3 columns. So this is a 2 by 3 matrix. So I have 10, I have 35, I have 25, I have 15, I have 45, I have 50. So if I were to factor out this matrix by using a common factor, I'm bringing a scalar, I see that out of this 5 is common. So if I bring out 5 outside and put this matrix, my resultant here, simplifying this one, 10 divided by 5 is 2. 35 divided by 5 is 7. 25 divided by 5 is 5. 15 divided by 5 is 3. 45 divided by 5 is 9. 50 divided by 5 is 10. So this is the factored form. The scalar is outside, and this is the matrix. So this and this are the same actually. All right. So that is for multiplying a matrix by a scalar, or you can factor out. Then the final one is multiplying 2 by 2 matrix. No, sorry, multiply 2 matrices together. Okay. So for multiplication to occur, before you multiply a matrix or 2 matrices, before you multiply 2 matrices together, you must ensure that the number of row of one is equal to the number of column of the other. So 2 matrices can be multiplied together when the number of column in the first is equal to the number of row in the second. What do I mean? If I have this matrix A11, A12, A13, A14, A21, A22, A23, A24. If I were to multiply, ensure that the number of column, how many columns do you have here? 4. Okay. The number of column must be equal to the number of row. Okay, let me stop at this point so so I can understand the concepts. I don't want to do complex one. This one is a single matrix, single column matrix. So that if I look at this one now, and this one is the same thing, the number of column must be equal to the number of row. So 2 matrices can be multiplied. 2 matrices can be multiplied if the number of columns in the first is the same as the number of rows in the second. Is the same as the number of rows in the second. Okay, so this is it now. This is the first matrix, the second matrix. The number of columns in the first, 1, 2, 3. There are 3 columns here. 3 columns here. If we check this one too, also 3 columns. So that what will happen? So that this one will multiply this to form a new matrix. That's to form a new matrix where the first element is this times this. This will multiply this to form a new matrix where the elements, so you are multiplying it like this. You multiply each of these terms by this. Okay. I will take this one off now because we don't need the objective again. We are in the last one. So I've finished. This is the last objective that we have to do in this class. So I'm going to put it on the board for us to see. So if I have matrix A defined as A11, A12, A13, and A21, A22, A23, and matrix B is defined as B1, B2, B3. Multiply A times B. This is the instruction. So we are doing this one now. So we say that they can only multiply if my column, number of column C is equals to R by number of columns. So I have 3 columns, I have 3 rows here. So the new matrix A times B, the new matrix A times B is equals to, so I take A11 dot B1, A12 dot B2, A13 dot B3. This is that one. So I've done this side multiply by this side. First row by first column by row. Second column by row. So the second row in the new matrix is A21 dot B1, A22 dot B2, and A23 dot B3. This is just the summary of notation of matrix. That's the summary of notation of matrix. So I'm going to try it for a particular example. We're going to try for a particular example and see how it will go. Of course, there are complex ones, so we are going to take that complex one to the next class. That's why I say you should stay tuned. Always subscribe to our channel so that you can get all these videos complete. So let me give us an example quickly. Okay, example number 1. So again, I say again, subscribe to our channel. So example. So if I have this matrix 4, 2, 7, 3, 6, 1 multiplied by 6, sorry, this 8 here, 8, 5, and 9. Okay, so we should multiply. This there's a dot here showing that we should multiply. So the new matrix that will come out from this place, we have the first element 4 times 8, 32. Then second element 7 times 5, 40. 6 times 9, 7 times 5 is not 40, 35. 6 times 9 is what? 54. Okay, 6 times 9. So the next one, 16 times 8. 2 times 8 is 16. 3 times 5 is 15. And 1 times 9 is 9. This is the answer. So you see the pattern. All these ones, everything here like this, multiply everything here to form the new row, and everything here, see, multiply everything here to form the new row 2. Okay. All right. So it is just very easy. Just very easy. Okay, now there is something we need to do to wrap up this particular one. It's not just like forming a positional array of these numbers. We are expected to add up this. Now, the destination for multiplication of matrix, the destination of the matrix should be like the multiplicand. So we're going to add this because at the end of the day, we're going to be getting what looks like this. We're going to add up this to get the final matrix, which will be a single matrix. So by the time you add this one, you get 1, 2, 1, and by the time you add this one, you get 40. So this is the answer for the multiplication of matrix. So if you are multiplying a matrix like this one, we ensure that first of all, the number of the columns and the row is equal. So when you have done the elemental multiplication, you add up everything. So the final matrix should look like the multiplicand. Okay, should look like the multiplicand. Okay, of course we're going to do a more complex one. Let's do one more example, and we'll wrap up the class. One more example. Okay, stay tuned, please. All right, so for this one, I have this matrix 2, 4. I have 3, 6. I have 5, 0, and 1, 7. Multiplying this other one. 3, 4, 2, 9. So 3, 4, 2, 9. So we're going to do this matrix, and first of all, I identify that this one, the number of columns here is 4, and number of rows here is 1. I'm saying 4 as well. So we're going to match the matrix one by one, then add up to get the final answer. So for this one now, just have a new matrix like this, where you have 2 times 3 is 6, plus 3 times 4 is 12, plus 5 times 2 is 10, plus 1 times 9 is 9. Second row, 4 times 3 is 12, plus 6 times 4 is 24, plus 0 times 2 is 0, and plus 7 times 9 is what? 7 times 9 is 63. So we're going to add up the matrix so that we can have the same pattern as the multiplicand. That's same, just one row, one column. So when I add all together, I have 37 and 99. Okay. So I hope this video has been informative for you, and I'd like to thank you for viewing.